Good day, viewers. Yeah, welcome to another learning edition with Achievers Tutorial. And today, the topic before us is mole concept in chemistry. This topic has been found to be what a disturbing one to students, and we say today let's try and make it more easier for our own understanding. Now, when you say mole is the major way of measuring chemical values, and it can also be said to be the amount of substance found in what? In the Avogadro's number, which is 6.023 times 10 raised to the power 23. Now, when you are using mole to calculate, it has various parameters. Because of it is diversified, we can use different formulas to attain our mole. So come with me, let's explore the various parameters using different formulas to attain this mole. Number one, when it involves known masses. Now, when it involves known masses, you simply say mole, and we all know that mole is noted with small letter n. We can simply say mole is equal to what? Your mass over what? Your molar mass. And you know your mass is measured in grams, and your molar mass is measured in gram per mole. We all know. Secondly, when it involves solutions, you simply say your mole, which is noted with small letter n, is equal to what? Your concentration measured in what? Mole per dm cube. Mole per dm cube times what? Your volume measured in what? dm cube. Now, third one, when at STP simply means what? Standard temperature and what? Pressure. You can say at STP, we can say mole is equal to what? Volume over what? 22.4, which is your GMV. The fourth one, when it involves number of particles. When we say number of particles, we simply mean elements, molecules, or atoms. We simply solve it as what? Okay, let's say number of what? Particle. We simply say what? Mole is equal to what? Your number of particle over what? Your Avogadro's constant, which is 6.023 times 10 raised to the power what? 23. Sometimes you just put okay. Let's do it like that. Now, the fifth one, when it involves ideal gases. And we all know that when we talk about the gas laws, we have the ideal gas and we have the rare gas based on their what? Their pressure and temperature. Because there's always the deviation between two of them. So when it involves what? Ideal gas, you simply say what? Mole is equal to what? Your PV over your what? Your RT. And you know that your P stands for your pressure, your V stands for volume measured in what? Let me indicate that volume is measured in dm cube. So if you have been given questions in cm cube, just have it in mind that you divide by 1000 to attain your dm cube. Your R stands for your gas constant, and your T stands for temperature measured in what? Kelvin. Okay, now let's try our hands on some questions from the past question. This number one question: what weight of sodium chloride is needed to make 2.0 dm cube of 1 molarity of the solution? Now, you need to know that molarity is a unit of concentration. Just like we have mole per dm cube, we can also use molarity in concentration. So, now, first of all, the first thing you do when attempting a question is to bring out the parameter. State the parameter so you don't get confused. What was given? The first one that was given is what? 2.0 dm cube. So your volume is 2.0. The next thing is your what? Molarity, which is your concentration, is 1.5 molarity. This one is dm cube. So now, and we're asking for the weight. Now, you know weight simply means mass. First of all, what you do? You first get your what? Your mole. Your mole, which is equal to what? You know when it involves solution, you simply say concentration times what? Volume. So what's your concentration? 2.0 times what? 1.5 to give you 3 mole. Now, but we have not gotten our answer. The question says, what is the weight? Now, since we have gotten our mole, we have to recollect and take our mind back to the first formula we deduced, that when it involves masses, you simply say mole is equals to what? Mass over what? Molar mass. And we know that the molar mass of sodium chloride, sodium is 23, chlorine is 35.5. So if you join 23 plus 25.5, it will give you some 58.5. So I can say mass of chlorine is X. Mass of sodium chloride is X. Then your molar mass of sodium chloride, you can say 23 plus 50 plus 35.5. See, you are looking for your mole. Your mole is still there. So X over what? So 58.5. What is your mole? It got to be what? 3. So you cross multiply to have X is equals to 3 times 58.5 is equals to what? 175.5 grams. Since we are looking for what? The weight. So that should be option D in the question. This is 2007 question, 14 question. We can go and verify. Okay. Now we'll be able to answer number 1. Let's move to number 2. Now the question number 2 was gotten from 2007 question 18 past question JAMB. Now calculate the number of moles of HCl present in 20 cm cube of 0.75 molarity of the solution of the acid. Now the first thing you ask yourself, the word molarity, I told you before earlier that we will use it what in aspect of what in respect to what concentration. Now another mistake, students often make this mistake using cm cube when calculating. No, it is very wrong. Either you convert it to dm cube before solving, or doing your solving divided by 1000. So now let's go please. The parameters given was volume is what? 20 cm cube. Then your concentration is what? 0.75 molarity. So to find our mole, you simply say C times V. What's my C? 0.75 times 20 divided by what? 1000. So your final answer will be 0.015 mole. I guess it's easier. Or you can divide your 20 by 1000 before solving, or doing your solving, you cannot divide it at once. Okay, solving this number 3, how many grams of HCl will be required to react with 5 grams of sodium hydroxide? And we're giving the masses of the molar mass of the elements involved. Now, there is something you need to know. When solving questions in mole concepts, there are various ways the questions can appear. The first one, it may just appear in a compositional form. In that compositional form, you need not to balance any reaction. Just go straight to the point and solve. Those are the ones we've been solving. But now, there are some that you need to balance a reaction before you can attain your required parameter. Now, see something. See something now. See something. How many grams of HCl will be required to react with 5 grams? This reaction is between HCl and sodium hydroxide. Okay, balancing a reaction between HCl and sodium hydroxide. We know HCl is an acid, sodium hydroxide is a base. So when an acid reacts to the base, such a reaction is called a neutralization reaction. And what is the yield? What does it produce? It produces what? Salt and water. So HCl plus sodium hydroxide to give us sodium chloride plus what? H2O. We all know sodium chloride as common salt, right? So now what's the molar mass of HCl is 36.5, while the molar mass of sodium hydroxide is 40. Now comparing these two, the mass of HCl is what we are looking for. I can put X here, and the mass of this one was given, which is what? 5. Because multiplied to half, so I can say 40 times X equals to 36.5 times 5. Dividing both sides by 40, dividing both sides by 40. So X is equals to what? 4.56, which is approximately 4.6 grams. Thank you. To get notifications of more of our videos, you can click the subscribe button, like our pages, share to your friends. We are here to help you in Achievers Tutorial.